All right, we're going to transform functions today. So we're going to take different functions and shift them up, down, left, right. Here's our learning goal for today. To use vertical and horizontal shifts to sketch graphs of functions, we're also going to use reflections and transformations, like scale changes, stretches, and shrinks. All right? So here's the book's notation, which can be a little confusing, but basically if you add or subtract a number outside of y, so outside of the parentheses of x, then that's going to shift the function up or down. And if you add or subtract a number inside of the parentheses that involve x, then you're going to shift the function to the left or the right. I think the best way to look at this is some examples. So for this one, if I have, this is a cubic function, and if I have x cubed, which a rough sketch of that looks like this. So here's y equals x cubed. Now, if I take x cubed and subtract 1, it's going to shift it 1 unit down. So this red function then is the new function. Okay? Y equals x cubed minus 1. When you subtract 1 outside of x, it shifts it up or down. In this case, when you subtract 1 outside, it moves it down. Now, to follow consistently, some people like to move the number over the other side as y plus 1 equals x cubed. And that way, the same property holds for x and y, where if you add a number outside of y here, it moves it, you think it would move it up, it moves it down. And the same is true about x. If you were to add a number like 1 inside of the parentheses, you think it would move it to the right, but it moves it to the left. So when you add something to y, it does the opposite, but it does stay in the vertical direction. When you add or subtract something from x, it does the opposite of what you think in the horizontal. So some people like to remember it that way. I personally do, but whatever works for you. Here's another one. This is the same cubic, so it's the same blue parent function, but now our new function is going to be shifted 2 units to the left and 1 unit up. So I'll take this point, move it 2 units to the left, 1 unit up to here, in which case you'd have this right here. It's really helpful to know how to shift functions because then all you have to know is your basic functions like y equals x squared. Obviously, is a parabola that opens up. Okay, you know y equals x is a line that goes like this. Y equals absolute value of x, which is a v, like that. Y equals x cubed, which is a cubic, like that. Then it follows the same pattern. Y equals x to the fourth now goes back to a parabola. X to the fifth goes back to a odd function, and so on. But those are some of your basic ones. You know, even if you have like the y equals the integer function, integer of x function. This one we know is a step function like this. Well, you can also shift this one right or left or up or down. It's pretty bad, but. You shift the whole function. Yeah, some more, you know, there's a bunch of basic functions, but y equals 1 over x would be this function. You can shift that one as well. So we're going to shift all these functions today. Let's talk about reflections as well. If we have a negative sign outside of y, then that's going to reflect it over the y-axis. For example, if you take y equals x squared, we know that's the parabola that opens up like this. If you take a negative sign outside the function, outside of x, it's going to flip over the x-axis. It's going to look like this, up and down. Okay? That's the first case, reflection over the x-axis. Now, if you change the sign in this case, in this one, if you were to change the sign inside of the parentheses, inside of x, to a negative, that wouldn't matter because you'd reflect it over the y-axis. This thing's symmetric about the y-axis. So if you did it in this case, this negative sign would go positive. You'd have y equals x squared, which is the original function back. So this one, if you reflect it over the y-axis, it doesn't change at all. But one like a line maybe, this line y equals x. If I change the sign on the x to a negative, then it does reflect over the y-axis, so then it goes down like this. Okay, it's reflect over the y-axis. Okay, so we have, let's have a parent function of y equals x to the fourth, which is basically parabola. Okay, this is our parent function. Now, I'm going to take it and I'm going to reflect it over the x-axis and shift it up 2 units. And I want you to write an equation. So go ahead and write an equation, try pause it and write an equation for this one and for this one, and see if you can get the right answer. This one's shifted over 3 units to the right and reflected down over the x-axis. So go see if you can write equations for these based on our regular transformation. You should get this if you do the first one. This parabola right here, is to reflect it over the x-axis and move it down, you need the negative sign outside of the x. And then if you add 2, that's going to end up translating the function 2 units up. One thing you could do to look at this too is look at an xy table. When you add 2 outside, for example, your x's stay the same in an xy table, but what happens is your y's are all 2 higher because of this. So obviously it's going to shift it up 2 units. So, all right, let's try the next one then. What would the equation be for this one? Awesome. Yeah, it'd be y equals negative quantity x minus 3 to the 4th power. The minus 3 on the x moves it 3 units to the right, and this negative sign is shifting it or reflecting it over the x-axis. There'd be the equation for this translation if the parent function was y equals x to the 4th. Next is vertical stretches, shrinks, and horizontal stretches and shrinks. This is what the book has to say. Basically, if you multiply y by a number, multiply a number outside the function, that number is bigger than 1, it's a stretch. If that number is between 0 and 1, it's a shrink. And then the same thing for x. If you multiply x by a number and that number is greater than 1, it's a shrink. So it's the opposite. And if that number is between 0 and 1, it's a stretch. Let's take a look at an example of that. Here we have the parent function is the absolute value of x, which is this gray one. And if we multiply a 3 outside, then that's going to be a vertical stretch. So this gives us a vertical stretch and by a factor of 3, because that's what that is, that number. And you would just say vertical stretch for this, and it makes sense if you look at the graph. It's stretched vertically, so these branches move up. Okay, and it makes sense if you look at a table too. You're sticking in the same x values, but then those x values get multiplied by 3. So in your xy table that you make, all the x values would be the same, for example, but now all your y values are 3 times bigger. So when you go to graph these points, these y values are higher, which means it's going to end up being vertically stretched. So it shouldn't be too complicated, hopefully, for this to make sense. If I'm multiplying 1/3 out, that's going to have the opposite effect. This is going to be a vertical shrink. Because all your x values you stick in are now going to be multiplied by 1/3 to get your new y values, so they're going to be smaller.
So if it's greater than 1, it's a stretch?
Just real quick. Let's try another one. Let's say I had a parabola y equals x squared, and I want to take this function, I want to stretch it horizontally, so I want to move these branches out and flatten it out, which, by the way, would be the same thing as a vertical shrink. But let's say I want to do horizontal stretch by a factor of 2. By a factor of 2. So what would the new equation be? Why don't you try to do this one? Okay. So we want to multiply, this should be the answer right here. You want to multiply x by a number that's less than 1. And specifically by 1/2. Let me explain. If you think about this, this is the same thing as a vertical shrink. Moving these branches down would be the same thing as moving them out, really. So if you look at this, when you take this 1/2 and you square it, that'd be the same as 1/4 x squared. You square what's inside the parentheses. In which case, multiplying a number outside that's less than 1 would be a vertical shrink. So it's a vertical shrink or a horizontal stretch, however you want to look at it in this case, and the parabola will be more flat. You can graph both these in the calculator just to make sure. So go to y equals and graph x squared, and then graph, however you want to graph it, I'll graph it this way, 0.5x, and then it's all squared. And one's blue, one's red, and the red one should be fatter, it should be wider. So you can always check these and make sure if you're on the calculator portion that it is. Okay. All right, awesome. We're gonna have to practice some of these. I hope this helps a little bit, but we're gonna have to make a homework help video and go over these. These transformations just take practice.